In the previous video, we have group process and explore about our data, and we need to proceed to further steps. So the first thing is to import the necessary libraries and loading the dataset first. And we also need to get only the numerical value first, since multiple linear regression only accept the numerical values. And we use num columns to define which column is numeric by using its numeric function and supply for each columns. And num data is to store the actual data of numeric columns. And we also drop the number 1 columns, which is the customer ID columns. And we use code names to show the result of this. And you can see this is the numerical values, and the total spend is the target variables. So we proceed to the correlation analysis by using core function, which calculate each variable's correlation by using Pearson correlation. And we're using heat map to show the result of the correlation analysis. And we put the core matrix in here and display the number of correlation result and colors and the titles. So you can see in the heat map, the total spending have a strong positive correlation with item purchase and average rating, and have a moderate negative correlation with age and days since last purchase. And we also mentioned that the item purchase and average rating have a strong positive correlation, so we're gonna remove the average rating. After that, we develop our model using the LM function and define the target variable first, and the following are the independent variables. And we use summary model to show the result. And this is the result. And the intercept is meaningless here, since if age, item purchase, and those things are 0, the total spending wouldn't have this amount, as it is not possible in real life. And this were the slope of the variables. For example, if age is increased by 1, the total spending will decrease 4.4. And if an item purchase is if an item is additionally purchased, then the total spending will add 75. And if an additional days is added since last purchase, then the total spending will decrease 4.5. And this is the p-value for hypothesis testing. For null hypothesis, it shows that the variables has no effect to the total spending, but since the variables of this have a very low p-value with smaller than 0.05, which means that this value has effect on the total spending. And we also see the R-square, which means that this model has explained 96% of total spending with using these variables. And that's it.